Hey kids, it's Mr. Malzberger here with another lesson about exponents and roots. Today is our second lesson, and we are going to talk more about cubes and cube roots. So here we go. Cubes and cube roots. In the first lesson, we learned exponents are how many times you multiply a base. So if our base is 4, we have the power of 3. It's the same as 4 times 4 times 4, which is 16 times 4. That's 64, right? So cubes, the reason they're called cubes is because a square has two matching sides of 4, because it's 4 at the base, 4 at the height. This won't be perfect. A little bit too long, but also has a length of 4, right? So 3 4s is a perfect cube. 3 5s is a perfect cube. 3 6s is a perfect cube. Now, cube roots are the exact same concept of taking a root as a square root. A square root, you're looking for what number times itself twice is that number. Well, with a cube root, the only difference is you'll see a little 3 right there. The radical sign without any number is a square root. Every other root, you can take a cube root or a fourth root or a fifth root, whatever it is, it'll say it right there. And of course, this will be housed underneath on your homework. The line stops right there because I did it on a Google Doc. So it's saying, what number are you going to get to multiply by itself 3 times to get 64? And you know it's 4. One thing that's interesting about cubes is that you can actually have cube roots of negative numbers. You can't take the square root of a negative because no negative times a negative will still be negative. Every negative times a negative is a positive, and every positive times a positive is a positive. It's a lot of positivity. But cubes, since it's an odd power, you can have negatives. So I could have, what's the cube root of, say, negative 8? You can say, well, that's going to be negative 2, because negative 2 times negative 2 is going to be positive 4 times one more negative 2 makes it negative 8, right? So, let's see. What else do you want to know about these wonderful things before I get into the wonderful math pattern of how I'm going to have you just use a little bit of head math to figure out cube roots here. Oh yeah, fractions. Fractions, just like in square roots, are the same kind of concept. I know that 5 cubed is 25 times 5, right? And I've memorized another one. So if I gave you the cube root of this fraction right here, it's just like the square root of a fraction. It's just 2 separate problems. They don't even interact really at all. So 5 times 5 times 5 is 125. And 7 times 7 times 7 is 343. So the cube root of 125 434ths is 5/7. So let's look at the perfect cube chart that I attached. Now what I want to show you here is just a simple number pattern. Now I doubt there's going to be many opportunities in your life where you're going to go out and get to brag and show that you can solve or figure out the answer, the cube root of any perfect cube between 1 and 1,000,000. As long as the number's a perfect cube, by following a simple pattern. So here we go. First thing we're going to do is we're going to look at your perfect cubes 1 through 10. Because these numbers are very important. These are the numbers you can memorize and then solve every double-digit number cubed. When if you got its number, you could figure out what it is. I'll show you how. Okay, so most of these are pretty easy. 1 cubed is 1, 2 cubed is 8, 2 times 2 times 2. 3 cubed is 9 times 3. That's how I like to think about it. I like to think of the perfect square times one more. 4 cubed is 16 times 4, 64. 5 cubed is 25 times 5, 125. 6 cubed is where it starts to get a little bit bigger. That's 36 times 6. 6 times 30 is 180, and 6 times 6 is 36. So 180 plus 36 is 216. The way I think about 7 cubed, it's 49 times 7. So I do 7 times 50 in my head, which is 350. That's easy. And since it's 49 sevens, I take 7 away, 343. 8 cubed, I always like this one because 512 is in that game, 2048. And this is 256 plus itself. It's just one of the patterns. Yeah, anyways, 64 times 8. 9 cubed is 81 times 9, so 80 times 9 is 720, and 9 times 1 is 9. Now the tens, they're kind of in their own little category. 10 cubed is 1,000. 20 cubed is 8,000. 30 cubed is 27,000. Guess what 40 cubed is? Well, 4 cubed is 64. And 3 cubed is 27, and 30 cubed is 27,000. So 4 cubed is 64 means 40 cubed is going to be 64,000. 50 cubed is going to be 125,000. 60 cubed, 216,000. 70 cubed would be 343,000. 80 cubed, 512,000. And 90 cubed, 729,000. Why is that at all important? If you can memorize these or just have just this part of the chart, I'm going to show you using the other ones. But you don't need to even memorize these at all. I don't know any of these. None. I kind of remember this one, the 11, because it's a cool pattern. But I don't know any more than this one, because that's all I need to solve any perfect cube that has a base, a double-digit base. So here we go. So let's look at the ones digit of the answers. 1, of course, is 1. 2 cubed ends in an 8. 3 cubed ends in a 7. 4 cubed ends in a 4. 5 cubed ends in a 5. 6 cubed ends in a 6. 7 cubed ends in a 3. 8 cubed ends in a 2. 9 cubed ends in a 9. 10 cubed ends in, we're going to ignore we don't really care about the tens. They ends in zeros every single time. They're the part that we need to memorize these for. 11 cubed, check this out. So 11 cubed ends with a 1. 12 cubed ends in an 8. 13 cubed ends in a 7. 187. 187. Well, this goes 4, 5, 6, and this also goes 4, 5, 6. And then 3, 2, 9 in the ones column. 3, 2, 9. It matches. It's the exact same number pattern. The ones digits of these single cubes and the ones digits of these teens cubed all end with the exact same ones digit. Now let's look over at the 20s. 21 ends with a 1. 22 is going to end with a 8. So 187, 187. 4, 5, 6, 4, 5, 6. 3, 2, 3, 2, 9. We're going to ignore the tens. Now, if you look at it, you'll see that this is kind of like a weird sandwich in a way. Up here, the 9, and down here, the 1. The 9 and the 1 add up to 10, right? And they both end with their numbers. This is like the real thin, like, you know those, ever seen those diet bread things people have? They're like little thin breads, and they make sandwiches out of them because they're only 100 calories or something like that, or whatever. They're really thin bread. Now in the middle of this double-decker sandwich, we have a really fat piece of bread. The 4, 5, and 6. They end with their numbers too. So 1 and 9, and the 4, 5, and 6. So 5, the middle number, and the numbers that surround it are all ending with their exact same numbers. Now the meats are switched. Now let me, so these are buns, right? Bun, or bread. It's kind of like a twisted mathematical Big Mac. The meats are the reverse of their companion. Huh? What do I mean? Well, 9 and 1 add up to 10. 6 and 4 add up to 10. They're companions. They match up in the exponent world. Like when we looked at the perfect squares, it was the matches that had the same endings. 4 squared and 6 squared both end with 6s. 3 squared and 7 squared both ended with 9s, right? So 7 matches with 3, and 8 matches with 2. And they're switched. That's why I mean the meats are upside down, I guess you could say. 7 is 3 and 8 is 2. And 2 is 8 and 7 is 3. So it's not a perfect match, but if you can kind of remember this little sandwich pattern, I can give you any perfect cube and we can figure it out. Okay? Now, what we're going to just leave here that you can see is just this chart right here. We don't need the other numbers. Of course, you can look at them because it's a video. What am I going to do? Don't look at the paper. So let's look at the cube root of 13,824. Now, here's why we looked at the tens. The tens digits in these double-digit cubes all made the thousands. So we don't care about the hundreds at all. We don't care about the tens. These numbers are insignificant. We just care about how many thousands there are and what does the number end with. So how many thousands there are, this time it's 13. So what we do is we come back over to this chart and we say, where does 13 fall? 13 falls right here, right between 8 and 27. We're not looking at the bases before they're cubed, we're looking at the value of the perfect cube. So 13,000 falls between 8,000, right? 20 cubed is 8,000. 30 cubed is 27,000. So since it falls between here, we always look at the one below. This answer is going to be in the 20s. Now we go and look at the end number. Well, 4 is in our sandwich right here. Of course, you write this down, you don't need to remember all the bun meat stuff, but 4 matches, so this is 24, right? So let's do, I'll give you one that's maybe a little more challenging, and we'll see if it works, because that one is technically on your chart. So let's try this one. Okay, we're going to find the cube root of 157,464. If you want to pause it and see if you can do it yourself, you can. Do it now, because I'm going to solve it. All right, remember, we're looking at only 2 things. How many thousands? The actual number is not even that important. It's just where does it fall, right? 157 goes between 125 and 216, right here, right? And then we look down, we never go up, so this number is in the 50s. And look at that. It ends with a 4 again. How original of me. Now 4 ends with a 4, so it's 54, right? Yay, isn't that exciting? you should say, that is fabulous, Mr. Malzberger. We are so impressed by your skills. So let's do another one. 103,823. Okay, we're gonna find the cube root of that. Pause it if you want to do it yourself first. Okay, here we go. Let's check out the thousands. 103. Where does 103 go? It goes right here between the 125 and the 64. So looking down, we know that this is going to be in the 40s. And it ends with a 3. And 3 is one of the ones that switches because 7 is 3, so 3 is going to be 7. So this is 47. That is the root. Okay. So you have a cube root practice. There's 12 different problems on there. And I realized I made none of them negative. Ha ha ha. We'll do that later. To see mine, I've folded it in half. You can't see all of them, so you have to look at yours. Pause the video. I know you're like, this is way too many, but if you notice, a bunch of them are actually on your chart, so try it out. Ready? Okay, here we go. Let's see what you got for the cube root practice. Now, I realize some of these are actually going to be right on your chart, so you could have just looked over and said, oh, let me find it on the chart. But I'm going to do it the way I was showing you, the headway. Now, I know that anything under 1,000 is going to be in the single digits. So it ends in a 5, so this is 5. Cube root of 125 is 5. This is also under 1,000. Cube root of 64 is going to be 4. This is part of that 4, 5, 6 sandwich. Cube root of 729, also under 1,000, ends in a 9, so this is 9. Weren't those tough ones? Let's see, did I get really hard here? 512. Well, still under 1,000, so it's a single digit. Ends with a 2. I know that 2 and 3 were the ones that switched, so the pair of 2 is 8, right? Moving right along. Oh, we finally get 1,000 here. We've got 2,000. So I'm going to come over to my chart and say 2 falls right here because it's right after 1. So this is in the teens. I know that the teens are going to be between 1,000 and 8,000, right? All the teens, 11 up to 19, are between 1,000 and 8,000. I'm in the teens now. And it ends with the 4. I know 4 is one of the middle bun, 4, 5, 6, so this is 14 cubed right there. I'm still between 1,000 and 8,000, so I'm still in the teens. It ends with a 9, right? And 9's the top layer with 1. The outer layers with the sandwich, so that makes 19. Okay, moving along, I'll slide this up to the next 2 rows of problems. Okay, now I'm up to 13,000. Well, I know that 2 cubed is 8, and 3 cubed is 27, so I'm in the 20s right here, right? 2 cubed is 8, 8,000, 27,000 is where the 30s start. So I'm in the 20s. It ends with a 4. 4's in that middle sandwich again, so this is 24, right? Yay. Right here I've got 50,000. Well, that's above the 27,000 that makes the 30s and below the 64,000 of the 40s. So this is 30. It ends with a 3. And 3 is one of the ones that is switched, so its partner is 7, so that's 37 there. Over here we have 753, and that's below 1,000, below a million, really, right? It's below a million, so but above 729. So I'm in the 90s right now. It ends in a 1, and 1 ends with a 1, so 91. Last three. This one is 328,000. 328 falls between the 6 on the chart and the 7. 216,343. So looking down at the 6, I'm in the 60s. It ends with the 9, and 9s end with 9, so that's 69. Some people are laughing, going, ha ha ha. I'm happy to bring joy to your life. Let's do the two fractions. All right. Wow, this didn't print out very well. I've got 8 over 1,331. I know 2 cubed is 8, so 2 is my numerator. And 1,331, I know this one because it's a cool little number pattern. It's 11, right? 1,331. Only 11 would make that cool of a pattern. And then over here, I've got 216, which I know is 6. But the bottom is in the 29,000, so that's in the 30s, right? Because it's just above the 27. It ends with the 3. 3 is one of the ones that's not right, so it's 30. Whoa, wait a second. Do you see something strange? Do you? I do. I wrote 37 for this. I wrote 37 for that. This is the wrong number. But it ends with a 3. Let's see. Let's see what 37 cubed really is. 37 times 37 squared. Oops. Is 56. This is 37. Okay. Well, what number is this then? Let's see. Well, 31 times 31 squared is not that. I must have input the number wrong. I apologize for that one. So, you're probably like, what's going on here? This one doesn't follow the pattern. Yes, this is a Malsey mistake. Yeah. When I was growing up, this was before the days of apps on your phone that would tell you where to drive. My dad always was famous for the famous Malsberger U-turn because we'd miss where we were going and have to turn around. So in my dad's honor, I screw up your math problems. All right, so that is cubes and cube roots. If you're ever hanging out with your parents' friends, you can say, hey, grab a calculator and I'll show you how smart I am. Give me money. And yeah, you'll be the star of the party. Hope you guys are doing great. Talk to you soon.